Good morning, everyone. Welcome to the class on business statistics. And in business statistics, we have covered basically the understanding between the descriptive in statistics with reference to the inferential statistics. While talking about statistics, we discussed the statistics where we talked about the collection of data, we talked about classification and organization of data, we talked about analysis on data, and then we are right now discussing about diagrammatic presentation of data, where we are talking about the presentation of data. So when we talk about the presentation of data, when we are discussing about the presentation of data, primarily in the presentation of data, we mainly concentrate on different forms of presentation of data. Either we talk in the term of of tabular presentation, or we talk in the term of textual presentation, or we talk in the term of diagrammatic presentation, or we can talk in the term of graphical presentation of data. So when we talk about the diagrammatic presentation of data, when we are talking about diagrammatic presentation of data, in the diagrammatic presentation of data, while discussing the diagrammatic presentation of data, we discussed different forms of diagrams. So we discussed about line diagram, we talked about line diagram yesterday. We have discussed about line diagram. Then going further, we can discuss about bar diagram. So when we talk about bar diagram can be discussed into two part. Bar diagram can be horizontal bar diagram, or it can be vertical bar diagram. So we use horizontal bar diagram for the qualitative data, and we use vertical bar diagram for the quantitative data. Okay, and then going into the bar diagram, we discuss different types of bar diagram. In different types of bar diagram, we talked about simple bar diagram, we talked about multiple bar diagram, we talk about subdivided bar diagram, and we talk about percentage bar diagram. So in bar diagram, when we're talking about bar diagram, so we talk about simple bar diagram, we talk about simple bar diagram, we talk about simple bar diagram, we talk about multiple bar diagram, we talk about bar diagram, we talk about multiple bar diagram, we talk about subdivided bar diagram, we talk about subdivided bar diagram, we talk about subdivided bar diagram, or we can talk about percentage bar diagram, or we can talk about percentage bar diagram. So in bar diagram, we talk about different forms. So last class we discussed about simple bar diagram and multiple bar diagram. So in last class we discussed about simple bar diagram and multiple bar diagram. Now going further, we'll talk about subdivided bar diagram and percentage bar diagram in today class. So we're gonna talk about them. So while we are talking about subdivided bar diagram or percentage bar diagram, so you can we discussed subdivided bar diagram. So basically, if you can see in basically if you see in subdivided bar diagram, basically when we see in subdivided bar diagram or percentage bar diagram, basically we concentrate on one variable. So suppose that variable here is family A, and within that variable, if there are a lot of components are there, like there's a family A, it spends some money on food, then some money on house rent, some money on fuel, then others some money. So like that, they are family A, B, C. So what is the total? What is the way the family A, B, C spend money? So that is what given to you. So family ABC, they can spend money either in food or by paying rent, or they spend money in fuel, or they spend money in other components. So you can do the total. I can do the total of this. I can do the total of this. So the total of this I can do. So I can do the total of this. So this is when we talk about this total. When I talk about this total, these are 1700. is the total expense of family A. 3700 is the total expense of family B, and 5200 is the total expense of family C. So how they're using these expenses, these are given to you. Okay, so how they're using these expenses, this is given to you. What you can do using this data, what you can do, you can create a kind of diagram like this. So you can create a diagram like this. So when you're creating a diagram like this, when you're creating a diagram like, so if you're creating a diagram like this, so if you're creating a diagram like this, so with this can easily can understand the breakup of the expense of the family A. So the breakup, in what way they're spending that money. So in different component, that breakup of that expense you can easily understand by looking at this diagram. So this is called subdivided bar diagram. So is this clear, everyone? So this is called subdivided bar diagram. So you can do the breakup of the so this is subdivided bar. Now the same thing what I can do, the same thing I can discuss in the term of the same thing, the same data what I can do, I can same thing I can discuss the same thing here. I can discuss the same thing here in the term of percentage. I can discuss the same thing here in the term of percentage. Like, so in term of percentage, this is what 500 is what percent of 1700. So this I can find. So like this. So I can discuss the same thing in the term of percentage. So I hope you people know Excel little bit. Otherwise, we'll have a class on that. So I can discuss the same thing in the term of percentage. Fine. So the same thing can be discussed. So the same value I can get in percentage. So now the earlier we did this, we solved this problem by using the diagram like this. We created this. This is called subdivided bar diagram. So the same diagram, if the same calculation you do in the form of percentage, then it is called percentage bar diagram. Then it is called as the percentage bar diagram. So this is called as percentage bar diagram. The same thing, the same thing, I hope everyone understand how to get the percentage value. What is the percentage value? I hope everyone understand. This is 500 divided by 1700 into 100. This is basically this is basically this is basically 300 divided by 1700 into 100. This is basically 150 divided by 1700 into 100. Okay, 8 point some percent. This is basically 750 divided by 1700 into 100. You get 44 point something. So the same thing, you can write them in the form of percentage. I think everyone knows how to do percentage calculation. Basic maths, everyone knows. So you know this percentage calculation. So what, how to calculate percentage, you know that. Now if I plot the subdivided bar diagram on this data, this is called as percentage bar diagram. Then this is called as percentage bar diagram. Same thing. This is called percentage bar diagram. Same thing. There's no nothing difference. Instead of representing the data in the form of number, we can represent the same thing in the term of percentage. So then we call this as a percentage bar diagram. Clear, everyone? Fine, everyone. Anyone have any doubt? So I hope everyone understood the percentage bar diagram. Fine. So basically, when talking about the bar diagram, in bar diagram we talk about some diagram, we talk about multiple bar diagram, we talk about subdivided bar diagram, we talk about percentage bar diagram. Then the next thing what we need to discuss here is the pie chart. And the next thing what we need to discuss here in the diagrammatic presentation of data is the pie chart. So now same thing we can discuss is a pie chart. So you can suppose this is the problem. Suppose this is your problem. Suppose this is your problem. You can see this is your problem. So again the same thing. So a family is spending money on food, 1800 rupees money they're spending on food, 900 rupees they're spending on rent, 450 rupees they're spending on fuel, and education they're spending 450 rupees, and then miscellaneous they're spending 1800 rupees. So the total is 5400 rupees. Okay, so what I can do, I can find the angle. So angle means what? I can find the angle. Angle means what? I see 100% of data, 100% is 360 degree. Okay, and that is equal to 5400. I hope you are understanding. So the sum total of this is 5400. So 100% is 360 degree, because in a circle, when you talk about a circle, the total angle in a circle is 360 degree. So now you can find the angle corresponding to them. What is the angle? This would be 1800 divided by 5400 into 360 degree. So you do that, you will get 120 degree. For second one, you can do the same thing. For the second one, you can do the same thing. Second one would be 900 divided by how much the sum? 900. So 900 divided by 5400 into 360 degree. So you got 60 degrees. Similarly, you can do all calculation. So you can find the angle. So in a circle, the total angle is 360 degree. You can find the angle. So you can find the angle. You can find the angle. So you can. So you can find the angle like this way. So the total angle would be 360 degree. The total angle would be 360 degree. So I hope you understood. Using them, you can draw the diagram. This is called pie chart. This is called as pie chart. Using them, you can draw the angle, draw diagram. This is called as the pie chart. Anyone, any doubt? Anyone, any doubt? Anyone, any doubt? So this is called pie chart. So we should have basic understanding of pie chart. One minute. Solve this question, everyone. Everyone, everyone solve this question. Question number 9. See this everyone. This so cost of sugar in a month under the head raw material, then labor, then direct production, then others. So then raw material 12, then labor 20, then direct production 35, and others 23. So the total sum 10, and then this would be 5, 7, 8, 9. Okay. So find the difference between the central angle for the largest and a smaller component of the cost of sugar. So the largest component. So what is the angle? Central angle. Central angle. If I have to find the angle. So the angle. If I have to find the angle. So the angle of this would be 12 divided by 90 into 360 degree. That would be 48 degree. Then this is 20 divided by 90 into 360 degree. So this is 80 degree. Okay, this is 35 divided by 90 into 360 degree is 140 degree. And this is 23 divided by 90 into 360 degree. 23 fours are 46 twos are 92 degree. So what is the difference between the central angle? Okay, so component by largest and smallest. So 23 fours are 8 9. So what is the difference? So the difference, if you want to find, so the largest is being created by 140 and the smallest is created by 48. What is the difference? So 140, this is 1 minute. So this is 140, this is 140, this is 140, 1 140 minus 48. So the answer would be 92 degree. Clear everyone? Clear? Anyone have any doubt? Okay, fine. So everyone understood this. So this is about pie chart. So going further, now we need to talk about the graphical presentation of data. Now we need to discuss the graphical presentation of data. So when we talk about the graphical presentation of data, then probably in graphical presentation of data, we can divide data in the graphical presentation in the form of different graphs like histogram, frequency, polygon, frequency curve, or ogive. So before we talk about graphical presentation of data, let's try to understand the data when before we talk about the graphical presentation of data. First, let's understand the frequency distribution of data. Let's try to understand the frequency distribution of data. So when we talk about frequency distribution of data, so we can talk about in the form of simple or ungrouped frequency distribution, 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 or we can talk in the term of group frequency distribution, or we can talk in the term of grouped frequency distribution. We can talk in two forms. We can talk in the term of simple or ungrouped frequency distribution, or we can talk in the term of grouped frequency distribution. So basically, we talk in two parts. So what we need to understand here, basically that whenever we talk about a data, our data can be simple raw data. So like the way when you collect primary data or you have secondary data which you, it can be unscattered. Okay, so it dispersed. So that is called a raw data. So that basically we call that as a raw data. Raw data can be like this, something like this: 12, 17, then 19, then 27, then 23, then anything, then 13, suppose, then maybe 2, maybe 7, then maybe 37, okay, then maybe 43, maybe 32, okay, then it can be 48, 45, something like that, then 12, something. These are the data. Suppose you have data like this is called raw data. So how many data is there like this? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you have 13 data like this. Okay, the same data, what you can do, you can write the same data in the form of class interval and frequency. You can write the same data in the form of class interval and frequency. In class interval and frequency, you can write 0 to 9, then 10 to 19, okay, then 20 to 29, okay, then 30 to 39, okay, and then I can write as 40 to 49, something like this. So this is called frequency distribution. So grouping distribution. So you're writing the data in different groups. So you're writing the data in different groups. So you made a these groups are called class intervals. Okay, so where 0 is called lower class interval, where this 0 is called lower class interval, and 9 is called upper class interval. What is frequency? Frequency basically means how many times the data repeat. So you have total 13 data. So how many times data repeat? So how many numbers are between 0 to 9? One. There's a one number, then two numbers. So two numbers are there between 0 to 9. Okay, 10 to 19. 10 to 19 means how many numbers are there between 10 to 19? So 1, 2, 3, okay, 4. So 4 data is there from 10 to 19. So you can write here 4. Then 20 to 29. How many data is there between 20 to 29? 20, 29, 1, 2, 1, 2. Only 2 data is there between uh, between uh, between 20 to 29. Okay, so here this was 5 data was there. This was 5. Okay, so this was also there. Okay, then 30 to 39. How many data is there? 1, 2, sorry, 1, then 2. 2 data is there from 30 to 39. Then 40 to 49, how many data is there? 1, 2. Total how many data? So 2, 7, 9, 11, 13. This way you can write this data. This way if you're writing the data, it means we are writing the data in the term of class interval and frequency. Hmm. Thank you, Abhishek. Hmm. Thank you, Hemant. So is this clear with you? So you can write the data either as a raw data. You can have a raw data like this. So you can have raw data. You can either, whenever you have this, so you can have the data expression. You can either express the data like this. You want to do calculation. You can do calculation on this data. So any kind of calculation you want to do, we'll do the calculation on this raw data, or we can express the same data in this form, where we have class interval and frequency. Okay, everyone. I hope everyone understand. What do you know frequency? Frequency basically means number of time a data repeat within the class interval. So that is basically we called as a frequency. I hope everyone is clear with the term frequency. So here frequency basically means so within the class interval, how many times a particular data repeated. So that we called as a frequency. Fine, everyone. I hope everyone has understood this. Now, when you notice the class interval, when you see the class interval, like I wrote 10 to 19, then I wrote 20 to 29. So this is called upper. This is called upper class limit. This is called upper class limit, and this is called lower class limit. While this is called as lower class limit. This is called a lower class limit. Again, this is the lower class limit and this is the upper class limit. Clear, everyone? Anyone have any doubt? Okay, so see, now understand this. If you see the class, if you see the class interval like this, 10 to 19, 20 to 29, then 30 to 39, then 40 to 49. So this way, this is this class interval is basically called as discrete class interval. This is called discrete class interval or inclusive class interval. This is called discrete class interval or this is called inclusive class interval. This way, when you see the grouping, this is called discrete class interval or this is called as inclusive class interval. Everyone please understand. So we call this as a discrete class interval or we call this as an inclusive class interval. Okay, so what you need to do in statistics, guys, please listen this very carefully. So in statistics, what I'm teaching you, so everything whatever we are discussing, it is a part of normal distribution. So whatever we are discussing, it is a part of normal distribution, and because it is a part of normal distribution, so what you need to do, you have to convert the discrete class interval or inclusive class interval. You have to convert the discrete class interval. You have to convert the discrete class interval or inclusive class interval whenever you get a problem into you have to convert the discrete class interval or inclusive class interval into continuous class interval or exclusive class interval. You have to convert this into you have to convert the inclusive or discrete class interval into continuous or exclusive class interval. So what is continuous or exclusive class interval? Please pay attention here. So this like 10 to 20, 20 to 30, 30 to 40, 40 to 50. This is called continuous class interval. This is called continuous class interval or exclusive class interval, or it is also called exclusive class interval. This is called continuous class interval or exclusive class interval. If there is no gap, if there is no gap between the upper limit of this class and the lower limit of this class, if there is no gap, if there is no gap between the upper limit of this class and the lower limit of this class, then this is called continuous class interval. While if there is a gap, if there is a gap, you can see there's a gap. There's a difference of one. So you can see there's a difference of one. If there's a gap, if there's a gap between the upper limit of the first class and the lower limit of the second class, then this is called discrete class interval or inclusive class interval. While if there's no gap between the upper class limit of the first class interval and the lower limit of the second class interval, then this is called continuous class interval. Clear, everyone? Anyone have any doubt? So basically, you have to understand that whatever we are doing, whatever we are discussing, everything, whatever we are studying, everything we are studying is a normal distribution. Whatever we are discussing is basically a normal distribution. So in normal distribution, the data should be represented. The data should be in normal distribution. The data should be represented. We are discussing a normal distribution, and in normal distribution data should be represented in a continuous data form, in a continuous form, in a continuous class interval form, in a continuous class interval form. So we are discussing a normal distribution curve where your data should be represented in the continuous class interval form. So because your data should be represented in the continuous class interval form, so you need to understand then in case if you see a class interval which is discrete in nature, if you see a class interval which is discrete in nature, if you see a class interval which is discrete in nature, you have to convert the discrete class interval. Whenever you get a problem, you have to convert the discrete class interval into a continuous class interval. You have to convert the discrete class interval with a continuous class interval. So how will you convert the discrete class interval into continuous class interval? For that, find the difference. Find the difference. Find the difference. What is the difference you are getting? Difference. What your difference you are getting? The difference what you are getting is 1. Find the difference. Okay. Then apply the formula. This is called lower class boundary. This what you get this. So in continuous class interval, what you get, we call that as a class boundary. Okay, class boundary, class limit is same thing here. Here, in the case of continuous class interval, Lower class boundary or lower class limit is same thing here. So the lower class boundary or lower class limit, the formula for that here is same thing in the case of that is same thing in the case of continuous class interval. That is the formula you have to follow is lower class boundary is equal to lower class limit minus d by 2. You have to use this formula while upper class boundary while the upper class boundary is equal to upper class boundary is equal to upper class limit plus d by 2. You have to do this. So the difference is 1. So the difference is 1. So 1 divided by 2, that is 0.5. 0.5 subtract in the lower limit and 0.5 add in the upper limit. So by this way what you do, you make this continuous. So by this way what you do, you make it continuous. 0.5 subtract in lower limit, 0.5 add in the upper limit. With this we make this continuous. Clear everyone? Clear everyone? Anyone have any doubt? So 0.5 subtract in the lower limit and 0.5 add in the upper limit. So with this, you make this as a continuous class interval. This is called as continuous class interval. Okay, so this is called continuous class interval. So here there's a term called class width. There's a term called class width. Class width means the difference between upper class boundary, the difference between upper class boundary minus the lower class boundary, that is called class width, or the other name of this is also class height. So the height means the difference. What is the difference between them? That is called height. That is why class width, class height, class size, anything we can use. Clear everyone? Class clear everyone? So the here the this you can see the difference. Difference is 10. So this class width is 10. The difference. You can see the difference. The difference between the lower class boundary and the upper class boundary. You can see the difference. The difference is 10. Clear everyone? Can we go ahead? Now the next thing. Now the next thing what you can keep in your mind. Now the next thing what you can keep in your mind. Now the next thing you can keep in your mind is the class mark. Now the next thing you can keep in your mind is the class mark. Class mark basically means upper class boundary. Class mark basically means upper class boundary plus lower class boundary, upper class boundary plus lower class boundary divide by 2. This is called class mark. Class mark basically means upper class boundary plus lower class boundary divided by 2. This we called as class mark. So normally we represent this with X symbol. So that means 19.5 plus 9.5 divided by 2. So you'll get 14.5. This is 24.5, 34.5, 44.5. This is called class mark, the midpoint. So 19.5 plus 9.5. So 9 plus 19 is 28. 28 plus 0.5 plus 0.5 is 29. 29 by 2 is 14.5. So the the value what you get with the formula called upper class boundary plus lower class boundary divided by 2, that we called as class mark. Clear everyone? We called as a class mark. This is the upper class boundary plus lower class boundary divided by 2. Anyone, any doubt? Anyone, any doubt? Anyone, any doubt? Any question, anyone? Anyone, any question? So suppose if you see this question like this, now suppose if you see the question like this, like class interval is given to you like 10 to 20, then 20 to 30, then 30 to 40, then 40 to 50. The class interval is something given like this, and frequency is given like this, something 13, 19, okay, 9, 23, something like this. Your frequency is given to this. So the sum of you got is 40, 40 plus 40 plus 40 plus 50, 52. You will get the sum of frequency is 52. So 30, 39, 40, 40, 52. So 30, 39, 40, 40, 40, 30, 30, 1, 2, 3, 30, 39, 40, 40, 62 should come. 62 should come. Sum of frequency 62 should come. Okay, yeah. So sum of frequency 62 should come. Now here when we talk about a term called there's a term called frequency. There's a term called frequency density. Frequency density. There's a term called frequency density. Frequency density basically means frequency of the class. Frequency density basically means frequency of the class divided by the class width. Divided by the class. That is called frequency density. Okay, so if I ask you what is the frequency density, if I ask you what is the frequency density, what is the frequency density of 20 to 30? What is the frequency density of 20 to 30? What is the frequency of that class? So the frequency of that class is 17. Frequency of that class is 17. So that is 17 divided by class width. What is a class with 10? So the frequency density of this would be 1.7. This is called frequency density. Remember this formula. This is called frequency density. Clear, everyone? Clear, everyone? This is called frequency density. Okay, so once you understood frequency density, now the next term which you should understand. Once you understood frequency density, now the next term what we'll try to understand. Now the next term what we'll try to understand is the relative frequency. Relative frequency. Relative frequency basically means frequency of the class. Relative frequency basically means frequency of the class divided by the total frequency into 100. So the relative frequency basically means frequency of the class divided by total frequency into 100. So here if I ask you what is the relative frequency, if I ask you what is the relative what is the relative frequency of 30 to 40? What is the relative frequency of 30 to 40? The relative frequency of 30 to 40. What is the frequency of 30 to 40? That is 9 divided by total frequency 62 into 100. This would be 900 by 62. 900 by 62 means what? 450 by 31. 450 by 31 means 31 ones are 31. So it will be 140. 140. 140 means it will go by 4. So it will go by 4. So 140. So 140 it will go by 4. 140 by 160. 160 means 5. So it will be 14.5 something. That is the relative frequency of 30 to 40. Clear, everyone? Clear, everyone? Anyone have any doubt? Clear, everyone? Anyone have any doubt? So, so I believe no one have any doubt. You have understood what all I have done so far in the class. With this intention, I like to wind up the class. Thank you, everyone. See you all very soon for the next class. Bye. Take care, everyone. Anyone want to ask any question? Any question, anyone? Abhishek, Akhil, Ambika, Basit. Any question? Bhavan, any question anyone want to ask? Ganga, Pratibha, Raghu, Tej, Tejeswar, Yaswant, Satish, any question, anyone? You can, for books, Pooja, you can refer S.C. Gupta, S.C. Gupta, S.C. Gupta, or Lenin and Rubin. If you want more book, you can refer G.K. Sharma. Okay, everyone. I believe nobody have any doubt, so I'm ending the class. Thank you, everyone.